Hi, everyone. Hope you're enjoying today's sessions here. We'll do our best to try to keep the level good here. In our session today, we'll be talking about how can you secure and isolate customer data when you're building SaaS applications in AWS Serverless. First, just a round of introduction. So my name is Guilherme. I'm the CTO and co-founder at MerCloud. MerCloud, we build an e-commerce platform that's specialized for the B2B business. Think about like Shopify, but for enterprises like manufacturers, producers that they sell to other companies on the supply chain. If you guys want to reach out to me to talk about serverless in general, the topics we're covering here, or you want to know more about MerCloud, feel free to reach out using my socials there. I'll pass to Luciano.
Thank you. OK, Dave already gave an amazing introduction, so thank you for that. The only thing I want to add is that I'm working with James, who's going to talk at the end of today on this book called Crafting Lambda Functions in Rust. It's still an early release book. We have published the first 2 chapters only yesterday, but you can already get it today with a good discount, I guess. So that's the website. I have stickers, so if you like our mascot, come find me afterward. Cool. Very quickly about fourTheorem. Also, Dave did a great introduction. What I want to mention is what kind of things we do with our customers. We have a large variety of customers, from like small to big companies, startups to enterprises with hundreds of employees. We have been doing different activities: cloud migration, training, cloud enablement. We did a very interesting case study where we built a high-performance serverless application that is also published with AWS in the AWS blog. So come check that out if that's interesting. And if any of these things is interesting to you, come and talk to us. Another quick shout to AWS Bytes. That's the website where you can find all the episodes. We have, I think, almost 120 episodes at this point. So you can probably find lots of interesting stuff in there. And please, if you do, give us some feedback, because always looking for new ideas and things we can improve. OK, let's get into it. How do we define a multi-tenant architecture? There are actually quite a few different definitions if you look online. So let's try to come up with a simple one that we can agree on today. So basically, when we talk about multi-tenant architecture, we are thinking about a system, so some kind of software that gives value to our customers that we want to deploy as one unit. You can imagine it's like one server. It could be in multiple servers. That doesn't really matter. But it's more we are deploying only one unit, and that unit is serving multiple customers that we generally call tenants. Now, why this model is so interesting and why it's something that we have been talking more and more in the last decade, probably. I guess the main reason is because it helps us to maximize the utilization of our resources, which generally means that we can have better margins on our products, because we are going to try to get the best that we can from the infrastructure. And of course, we are going to try to sell some kind of product and reduce the cost of that infrastructure. And there are generally 2 competing models when we talk about tenancy. One model is where you share nothing. So basically, you have this unit of deployment, and for every single tenant, you deploy an independent unit, and every tenant is only accessing to the servers and the databases and the front end that are dedicated to them, and nothing is shared. Today, we're going to focus more on the opposite case, where basically we are going to try to share as much as possible and have different tenants accessing that common infrastructure. And of course, this is not always a binary choice. It's not like you are either single tenant or multi-tenant. There are lots of shades of gray in between. And here we can see an example where on the left side, basically we are sharing pretty much anything, because everything is separate. Every tenant gets its own deployment. On the right side, everything is shared. But in reality, most companies will have some kind of mix in between there. So in this example here in the middle, you are sharing almost everything except the database. Maybe you have some compliance or some regulation that you need to satisfy. And it's probably easier to get the certification if you manage to share the database and keep the data separated. Let's look at a little bit of a more kind of serverless AWS example. And this is still a bit abstract, but hopefully it reminds you of some applications that you might have built with serverless. So here we have two different users that we identify with this lovely chicken and the crab. And they are called user T1 and T2 because they represent two different tenants. So user T1 is in tenant 1, user T2 is in tenant 2. So if you imagine you are building some kind of web application or maybe a mobile application where you have an API, one tool that we are going to probably be using is API Gateway. So this is going to be the entry point for every request. Now, API Gateway has a very cool feature that is called Authorizer. And Authorizer is basically a mechanism that allows you to validate that the request that is coming in, it's something we can trust. So generally, you receive some kind of token or session token. And in the Authorizer, you can take that information and decide, I do trust this token, and I'm going to let the user proceed with the actual request to the backend. Or maybe you don't trust it, and you just block the user request there. And you can integrate that very easily with Cognito, which is another tool in AWS that allows you to do user management. Now, what we want to do here is basically at the authorizer level, once we validate the token, generally you can get also information about the user. For instance, you can know which kind of tenant do they belong to. But let's say, just as an example, that the authorizer authorizes this particular request. The request is going to go to the backend. If it's a serverless application, we're probably going to be using Lambda. And this is where things can get a little bit dangerous. So let's call it the danger zone. And the reason why this is the danger zone is because this is where our business logic is happening. So this Lambda will need to access data, maybe a DynamoDB table, maybe an S3 bucket. And if we are trying to share as much as possible of our infrastructure, in those two places, we are going to have data for both tenant 1, tenant 2, and maybe even other tenants. So now imagine that you have an issue with this Lambda. Maybe there is a bug in your code. Maybe there is some kind of security exploit where people can run arbitrary code. You might be in a session that belongs to tenant 1, and just accidentally, you will access data for tenant 2. And this is really bad. This can be really bad for the business. It can even destroy your company, depending what kind of business you are in, if your data is really, really sensitive. So hopefully today, we're going to be able to share a strategy that will try to limit the blast radius and kind of delegate some of the responsibility in terms of security to the AWS platform, rather than having you to be very careful with your own code. But before getting into that level of detail, let's review how Lambda security or Lambda permissions work in general. So let's zoom into this backend Lambda. And you have done AWS, so you know that in AWS, you cannot do anything unless you define some kind of role with a policy that grants certain permissions. So by default, this Lambda cannot do anything. It cannot even access this table. So to basically give the power to this Lambda to access this table, we need to write somewhere, maybe in infrastructure as code. I hope you can read that down there. But basically here, what we are doing, we are creating an execution role for this Lambda with a policy that says you can access this table and perform certain operations on this table. At that point, what happens is that inside the Lambda, when the Lambda environment is created, implicitly that Lambda environment gets credentials that are associated to that execution role. And those credentials will be able to perform the actions that we specified in that role. So if we created, for example, a DynamoDB client, and by default we are not giving any credentials, we are automatically inheriting the credentials of the current execution role. So we can actually execute this particular query where we say, OK, do a specific query, and this query has a key that is related to the current tenant. So we can see there that there is a variable called tenant, which somehow we got from our business logic. And this is where the scary things can happen. What happens if you can accidentally or maybe intentionally from a malevolent actor, if you can control that particular variable, then you can access any data from any table, from any tenant in the table. OK, let's try to step back a little bit, and let's quickly review all the different technologies that we are going to be using in this example today. So we already mentioned API Gateway. It's a great tool to build pretty much any kind of API, HTTP-based API on AWS. It is a little bit annoying that there are two flavors, REST and HTTP, but we don't have time to get into a rant today. We can probably do it later if you want. We didn't mention that there are some cool features like rate limiting, and we'll talk more about that later on. We mentioned authorization. Authorization is pretty cool because there are some built-in authorizers that you can just use and they work. But if you want to do something custom, as we want to do today, you can build your own custom authorizers with Lambda. So what is a custom authorizer? A custom authorizer is effectively a Lambda function with a predefined interface. You receive information from the current request, and you have to return a policy that says, this user can do certain things and cannot do other things. And by things, we mean requests to specific endpoints in API gateway. So you can run any logic that you want inside this Lambda, as long as at the end of that execution, you produce a valid policy that API gateway can understand. There are other cool things that you can do. For instance, you can even use this concept of a context to provide additional information that gets propagated to the backend Lambda. And we will be using this particular feature. So what we want to do in general is we want to build our own custom authorizer that can read the token, validate that token, extract the tenant information, and then enhance this context with some kind of authorization that then is a little bit more secure. We'll get into details in a little bit. And the last component that we mentioned is Cognito. And Cognito is a great tool when you have to do user management. If you ever try to build a user management system, you can do it. There are lots of libraries, but there are also so many pitfalls that I will discourage anyone from actually doing it. So you can probably use something like Cognito. The only thing I will mention here is that there are different strategies when it comes to storing users. You can generally store all the users in one single user pool. You can imagine a user pool like a table where you store all the users with their own attributes. And then you can use attributes to assign different users to different tenants. Or maybe you can create a different user pool for every different tenant. Or maybe something in between. You can have a class of tenants that are like premium tenants and they have their own user pool. And you can have other classes of users where you are sharing the user pool space. This is up to you, but what is important is that you need to have a process that you define up front, and you have to have automation so that every time that you are onboarding a new tenant, you can use that process to in a repeatable way, create all the resources that need to be created, all the attributes that need to be populated, and therefore you have a predictable process that you can repeat over time. Now I'll leave it to Gil to show you some interesting code.
All right, thank you, Luciano. Yeah, so we got some context here that help us to create like a mental model of how this architecture looks like, and also to understand what services are involved. Now we'll look at some code. We all love seeing some code here, right? So this is what our authorizer Lambda handler would look like. And we have a few things happening here, but the first one we want to focus is like, the user is sending us an authentication token. And here we're handling like JWT tokens. So the first step is to validate this. Okay, we'll get from the event headers, and we'll send that JWT to Cognito to actually verify if the user is who he's actually claiming who he is. Once we send that to Cognito and we verify the signature of this token, Cognito will give us a heads up. And it will say, okay, you can trust this user. This is a valid token. So we can now read the claims from this token. These claims, they contain like the user information and the tenant this user is associated with. So we can use in our code. The next bit here, we're going to assume an IAM role. And this is an IAM role that we created specific for this service. And we have two important things here to look at this IAM role. The first one is that we're restricting who can actually assume this role. And in our example here, we're saying only that Lambda authorizer can do it so. So no one else, if they have access to it, no one else can assume it. And the second part is where actually we said what are the permissions that this IAM role comes with. On our example here, we're saying you can perform pretty much any read or write operation on any of the DynamoDB tables from this service. This is kind of like the boundaries permissions for this IAM role. The next step there, when we're assuming the role, we're actually going to set a policy to this specific session. So this is a subset of the permissions that the role has itself. And here, we're going to lock this down and make more fine-grained control on this session. And we say, okay, for this session, you can actually only do query on this specific table. This is where we'll put the logic where we validate what the role of the user is. So if he has an admin, he can get more permission. If he just read only, we can have something like this. And the other important bit here is we're setting a condition to this policy, where we're saying, okay, you can access this DynamoDB table, but you can only access records on this table that they belong to the tenant partition that your session is linked to. And how do we do that? Is we actually tagging a session there with a specific key called tenant ID, where the value of it is the tenant ID that we're grabbing from the user token claims. This is how we can do that step. The last bit, this is pretty common, so we're just returning a policy to API gateway saying, okay, on this example, you can do a GET request on the slash route. And here, what Luciano highlighted, we can also return in the context some information that will be sent to the upstream lambda. And here, what we're doing, we're returning the tenant identification, so we can consume it. And we also returning the credentials for this session, for this role that we just assumed. So when our lambda needs to talk to DynamoDB, we'll create a new client using the session credentials that the authorizer sent to it. Yeah? And here's the question, why do we actually need to assume a role? Yeah? And we come from the principle that we cannot really trust the role that's assumed by your Lambda, because that's quite generic. We don't have control of that session creation. You'll be setting permissions to it when you're configuring, but you cannot set special conditions like, okay, only restrict to this particular tenant. So you can do that by code, doing your where statement there as code, but that's prone to bugs. Or an exploit can just end up accidentally leaking data from one tenant to another. Yeah? And also, if you're going after some compliance, that's not really compliance friendly. So this way, the authorizer will be giving you that fine-grained credentials that you can assume it. And even if your Lambda try to bypass that and force brute trying to access some other tenant, the request that will be rejected. This is an overview of how this workflow looks like. So the user sends that JWT token to API gateway. We saw our Lambda authorizer there. It's assuming the role and sending back the temporary credentials plus the user and tenant information to it. And this will be sent to Lambda, right? So I'm trying to access DynamoDB table here using those credentials, everything is fine. But if I try to change, access some tenant data from this DynamoDB from another one that's not related to that session, the request will just be rejected. Okay, we're covering DynamoDB here on our examples today, but what about other services? Can I do the same with other services? So using the same logic, like you can do the same with S3. So you can put a condition like on specific key prefixes. If you're using cloud search, you can also do that with indexes. And if you're working with Aurora for Postgres, you can do this. It's slightly different there. There's some gotchas. You'll be using row-level security instead, but you can still achieve the same result there. If you're using other services, then you pretty much have two options. One is to separate the instances, one for each tenant, if compliance forces you to. or otherwise, then you need to fall back to that in code. You need to put that where clause there, and you have to do that by yourself. Some other interesting thing here, when we're dealing with SaaS multi-tenant application, we have the problem about what we call the noisy tenants. We need to find a way to predict that some tenants will abuse the system, and this will end up affecting the overall performance of your system and also affecting experience from other tenants. So we need to find a way to put like some rate limiting on top of that. So would we need to actually create our own logic, our own rate limiting system? No, here we can use some built-in features from API Gateway. We have two things here. We have usage plans and API keys. Here, we're adding one extra component to our architecture here. That's the DynamoDB table, where we have a correlation of tenant and API keys. So every time we are onboarding a new tenant, we're creating an API key to it and putting on this table. So now, when we're doing, as part of our authorizer, we do all the steps we saw before, but at the end, we're gonna check on that table, okay, what the API key is for this tenant. I'll grab it and send to API Gateway. And then API Gateway will do the job of doing like the rate limiting, throttling for you. And every API key can be associated with an usage plan. So you have different tiers there. So you have your enterprise tier where you have higher limit, or you have like a freemium or trial level where you have much reduced numbers there. And then this way, API Gateway is protecting your API backend for abusing, and will be doing throttling for you. This is how our handler would do with that. So we need some logic there to fetch the tenant key from that DynamoDB table. And then on the response, all we need to do is to send that API key on that usage identifier key. We're running out of time, but just a wrap up here. So we saw that we can build multi-tenant SaaS application using our favorite serverless tools. We just need to be very careful with how we access this customer tenants data. We need to take extra care there to not leave anything that can end up leaking data from one tenant to another. That's not compliant. And also, observability here is a must and needs to be tenant aware. Why tenant aware? Because we need to look at these metrics and we need to understand who is using what and how much they're using. So we can identify when we have problems of, for example, performance in an application, to identify who's the tenant who is causing that. And then we can act on that. And another recommendation we do, don't try to do early optimization. You'll probably get that wrong. Instead, use metrics to drive that. First, find your bottlenecks, and then you act on top of them. We have there a link to a talk from reInvent a couple of years ago where they covered this topic. So if you're interested to read more or know a bit more about this observability on multi-tenant, we recommend you watching that. And to finish, so all the code we showed here on the slides is available in this repo. It's public, so feel free to check it out or even use it as a template if you're kicking off a new project. And we also have some useful links there to share with you on this topic. Thank you very much. It was a pleasure.